Okay, let's continue to solve the problem. This is example number 5.16. Determine the component of reaction that the ball and the socket joint at point A. We have a ball and socket joint. And we know that the ball and the socket joint has three unknown support reactions. Smooth journal bearing at B. Smooth journal bearing at point B. Oh, okay. And the roller support at point C. Roller. Oh, we have unknown support at point C. Okay. We have unknown support. Well, typically, for the smooth journal bearing at point B, the journal bearing has translational restrictions for these directions, right? But in this case, we don't have any external forces that can move this object to the x-axis or even, wait a minute, z directional movement. Let me see. Yeah, so we don't have any external forces to the x-axis movement. So in this case, we don't need to think about the x-axis support reactions. So only in this case, the z directional movement support reactions. So BZ. In this case, roller has CZ, one support reaction. This one has three support reaction, that is AZ, AX, AY. So how many unknowns? We have 1, 2, 3, 4, 5. So let's look at the problems. Let's draw the free body diagram. This is x-axis. Okay. Let's show all the unknown forces. Ball and the socket joint has three support reactions, but in this case, I believe the AX should be equal to 0 because there's no external forces that is associated with x directional translational movement. For the y-axis, AY, Now let's apply equilibrium equation. Oops. equation. Let's look at the first equation. For the x-axis translational movement, we have only ax. Ax is equal to 0. So that's lucky. We can find one unknowns directly. How about the ay? Ay is still 0. There's only one force is associated with y-axis direction. For the z, we have az, we have bz, yes, that's it. Alright, let's calculate the moment about the x-axis. So we have x-axis here. Let's choose point A because there are 3 unknowns are associated at point A. So if we choose the point A, then we can reduce a number of unknown variables. What other forces are? Okay, so it seems like for the x-axis rotation, this one create a clockwise rotation. So it's minus. And how about this one? This one create this one is counterclockwise rotation, so which is positive direction. This one also counterclockwise rotation. So let's write the equation. We have 900 Newton times, since we are finding the moment about the x-axis, the perpendicular distance in this case is this one, 0.4 meter. BZ create the counterclockwise rotation, so it's a positive x-axis direction. BZ times 0.8 meter. For the CZ, same thing, CZ times 1.2 meter. This one should be equal to 0. How about the y-axis rotation? This is y-axis. So let's still choose point A to calculate the moment about the y-axis. Seems like this one create clockwise rotation, so this is minus y direction. This one create a counterclockwise rotation, which is positive. So for the y-axis rotation, 900 Newton times the perpendicular distance in this case is this one, 0.4, and this is a minus sign. Z times the perpendicular distance is this one to the y-axis. For the z-axis rotation, this is z directions. I believe that there are no forces are associated with the z directional rotation, so it's z. We can find the CZ directly from this equation. So CG is 600 Newton. Once we find the CG, then we can find BZ from this second equation. So BZ is minus 450 Newton. So we got a negative sign, which means the direction of our assumption was wrong. So in this case, BZ is supporting downward directions. Okay, so we got a CG and the BZ. We can plug these two numbers here, BZ and CG. Then we can find AZ. AZ is 750. So remember, we can use this negative sign. We can still use this negative sign. So we can calculate AZ is minus 450 plus 600 minus 900. So AZ is 750. So you can see that CZ is 600 Newton and BZ is 400 minus 450. So BZ, the direction of the BZ should be downward directions. And then we can find AZ, which is upward direction. Upward direction. I'd like to let you solve this problem because I'm gonna ask this question as a quiz for this coming Tuesday. Okay, so I want you to practice with this example. There is no answer for this question, but I want you to figure out by yourself. Okay. Today we learned two learning goals. So first thing is we learned how to define the support reactions in three-dimensional spaces, and we solved the two problems by applying the equilibrium equations in three-dimensional space. Thanks for watching this short video. Have a great day.